Well, dear students, now I start here some definition about lenses again, and the first definition here, which is called as optical center of lens. This topic is not written in every book, even in NCERT. No mention about this topic here, but the topic is important and generally misunderstood by everyone. Generally, I have noticed. So simply I can say here, by definition, then I will draw diagrams. The point of intersection of principal axis of lens and ray of light which passes through the lens without any deviation. Any deviation is called optical center of lens. In case of thick lenses, the ray may be laterally inverted, laterally displaced, but no deviation will be there. I try to make you clear it. I told you that point of intersection of principal axis and ray of light which passes through lens without any deviation is called optical center of lens. I told you that name of lenses are diverging, converging. All rays get deviated, but if there is a point, there is a unique point, ray passing through that point is not deviated, may be laterally displaced. In case of thick lens, the lateral displacement may be observed, but no deviation. Try to understand by this diagram. In case of thick convex lens, actually this is convex lens, thick one. This has center over with this side, C1, C2 this side. So light fall here like this. Here the normal is this. It will bend toward the normal, may go like this. And here this normal on the surface is this. It will bend away from normal. But incidence ray and emergent ray will remain parallel. And this is called here optical center C. optical center C. In case of thin lens, generally lenses are thin. This much is called lateral displacement. Lateral displacement. चारों तरफ शोर का but actually deviation, what is deviation? The change in the direction of path is deviation. Direction same, angle between incidence ray, angle between parallel ray 0. So no deviation, but if lens is thin, it may pass the direction like this. So here you are noticing here that it is little away from pole P1 and closer to pole P2. This position depends upon radius of curvature. The optical center of lenses divides the thickness of lenses is the ratio of radii of curvature. That is, if this P1C upon P2C, then T1 upon T2 equal to R1 upon R2. If exactly R1 R2 equal, then only it will be center. So optical center of lens may lie within the lens, on the surface of lens, or outside the lens. Though I have spent more time writing. So the optical center of lenses may lie inside the lens, comma, on any surface of lens, or outside the lenses. I have drawn only figure for convex lens. Now I will be drawing the diagrams for concave lens. Double concave plane. Let me do it here. This is double concave lens, or what you call it is concave or convex. Concave. C1 now this side, C2 this side. Light ray fall here like this. Now it will be the normal here. So it will bend toward the normal. It may go like this. Maybe it will go over. Take a minute, sorry. थोड़ा प्रैक्टिस मांगता है डायग्राम ये. C1, C2. The ray fall like this. This is the normal here. So this ray will bend little toward the normal. Here like this. Bend to the normal, then it is normal here. Again it will bend away from normal. The ray was coming like this. Now after reflection it will go like this. So remain parallel. So here optical center is this. The ray was coming like this. After reflection it will remain parallel. So this is the case of concave lens. Now if it is plano-convex, or like this, radial curvature of plane surface supposed to be infinity. So here I take the ray like this. It was going like this. Here the central curvature to normal, it will bend for the normal. And here it will come out again parallel to this. यहाँ पर ये ऐसे होगा यूं, ये गई, ये यहाँ बैंड भी again come out. But remember here, in case of thick lenses, lateral displacement is significant. But if lenses are thin, then this is not there. So here the optical center is lying on the surface. Here, in case of concavo-convex, this is concavo-convex. This is radius is longer and this is smaller. So here ray is falling like this. Center here, so this is this normal, bend for the normal. And again here the somewhere center here, bend towards. एक मिनट भाई, बनाना ठीक भाई, sorry. This ray was going like this. It bend towards normal, this side, goes like this. From here, it is refraction. Bend away from normal. So it is lying outside. थोड़ा ये ऊपर पड़ेगी यहाँ पर. Then come out. दिमाग खराब कर देता है. Again here is a normal going like this, but again remain parallel. So it is the C here. So this way you can try and can tell that optical center of lens may lie inside lens, outside lens, on surface of lens. This topic has no mention in many books, but it is important. Now I come to the important point. Generally, this type of question is asked in competitive exam, like NDA, like NEET, AI, EEE, etc. principal foci of lenses. First focus. I have defined focus in case of mirrors, in case of spherical surfaces, and again here it is coming to you. Principal focus. First focus. It is the convex lens. Principal axis. So here now I take this line, we divide the thickness into two equal parts and rays parallel to principal axis really converge. First focus it is first focus here. So ray diverging from it become parallel to principal axis. यानी कि a diverging beam is rendered parallel to principal axis. Here a plane perpendicular axis is called focal plane. In case of concave lens, rays converging to a point after reflection through lens become parallel to principal axis. This is first focus. So I can speak here, you can make note of it. There is a point on principal axis. There is a point on principal axis of the lenses from which a beam, diverging beam, after reflection become parallel to principal axis in case of convex lens or converging lens, or beam converging to it after reflection become parallel to principal axis. This is first focus. But remember this definition, first focus. There is a point on principal axis from which diverging beam in case of convex lens or beam converging to it after refraction become parallel to principal axis is called first focus. Now second focus. Second focus. Convex lens, ray parallel to principal axis. Ray parallel to principal axis. Really converge to a point. This is second focus. Since this lens converge parallel beam at its focus, so it is called converging lens. In case of convex, double concave, बीच की लाइन बनाएंगे आप, ड्रॉ द मिडिल लाइन, पैरेलल बीम. Concave lens is also called as diverging lens because it diverges the parallel beam. These rays after refraction appear to diverge from point. First you mark the point, join this line here while drawing the diagram. Simple technique. Join this and then diverge. कितनी भी रे हों, but if they are all parallel, they will appear to diverge from focus. This point on principal axis is called second focus. Dear student, I am making you aware that in case of concave lens, People draw always wrong diagram. Remember the name, it is diverging lens. Rays parallel to principal axis or whatsoever be the rays, it will diverge. Sometime देखो ये भी जब हम फर्स्ट फोकस की बात कर रहे थे, ये हमारा फर्स्ट फोकस की बात करते हैं इसकी जो बीम कन्वर्जिंग टू इट, रे कन्वर्जिंग टू फोकस बिकम पैरेलल, तो ये भी उल्टा मोड़ जाए, अगर ये ऐसा मोड़ता तो कन्वर्ज होती। तो डाइवर्जिंग लेंस नाम याद रखें। व्हेन आई वाज स्टूडेंट ऑफ क्लास 12, ऐसी बातें कोई बोलता नहीं पढ़ाता हुआ, पर लेकिन बोलनी चाहिए। इन आवर बुक दिस कन्वर्जिंग और डाइवर्जिंग नेम वाज नॉट देयर। इन हिंदी कन्वर्जिंग लेंस इज कॉल्ड उत्तल लेंस, उत्तल, और नहीं सॉरी उत्तल है अपसारी लेंस, अपसारी नहीं अभिसारी, सॉरी अभिसारी, और डाइवर्जिंग का नाम था अपसारी लेंस। तो ये नाम अपसारी अभिसारी। तो इन आवर पेपर देयर वाज सिंपल क्वेश्चन regarding the two, but we were not in Hindi, they were given name as Apsari, Abhisari, and in Hindi in English version they were given as converging, diverging. So we could not, no one could solve this question. So please nomenclature should be clear to you, and don't be afraid of knowing the names, so many names of things. So this was all about some definition. Now in next video I will be telling you image formation.